Okay, yesterday we were talking about the theory of Docker. Okay, so why organizations use Docker? Okay, so I told you like there will be any software. Okay, so any software will have its dependency. Okay. So any software will have this dependency. Okay. So ఏ సాఫ్ట్వేర్ వర్క్ అవ్వాలన్నా కానీ దానికి ఒక డిపెండెంట్ సాఫ్ట్వేర్ ఇది ఉండాలన్నమాట డిపెండెన్సీ ఉండాలి. So if that there is no that dependency, okay, it is not going to work. Okay. So let's say you want one software. Okay, I have it in my laptop. Okay, I'm giving it to you. Okay. So మీ దగ్గర డిపెండెన్సీ ఉండాలి. మీ ల్యాప్టాప్ లో లేకపోతే that software will not work. Okay. So anything will have its dependency, be it a software, be it any code. Okay. So ప్రతి దానికి ఒక డిపెండెన్సీ అనేది ఉంటది. Let's say you want to there will be Java developers, right? So they are going to write some Python programming. Okay. So if they are just writing Python programming, okay, Python code, it is not going to work. Okay. So the code will only work. They should also have the Python software installed there. Okay. So then only the code is going to work. Python should be installed. So likewise, if you want to write some Java code, okay, we should have a equivalent Java software. So likewise, any software or any code should have its dependency. So yesterday I've given example of VLC media player, right? So it will also have some dependency. Okay. So sometimes if you see in your mobile as well, some apps will not be working because that app will be working on the latest version. Once you have not updated, it's not going to work as well. Okay. So like that, you should have dependencies. In Docker, what they have did is, so previously this was the problem we are facing. Though the software was given, because of there is no proper dependency there, it was not working. Because there was a mismatch between its software and dependency. So now in Docker, what they did is, if I'm going to give you a VLC media player to you, okay, you might be on like 32-bit operating system, but I have given you 64-bit operating system. Okay, but still I'm telling whatever dependencies are required for that software, I'm providing inbuilt on it. Okay, now it's not like searching for the dependency in the system. Okay, so I'm building the code plus dependency together. And I'm packing into one single package. Okay, so that single package is Docker image. Means I'm bundling together, or I'm wrapping it inside only. Okay, so the software whatever it requires, right? So the dependency also I'm keeping inside and bundling together into a single package, and it is called as a Docker image. Okay, so nowadays like all applications are being built as a Docker images. Why they are built as a Docker images? So suppose there is a software. Okay, so let's take Jenkins, because we already have seen Jenkins. Okay. So if I take a Jenkins Docker image, so there is a Jenkins software, and as I said, all applications are built as Docker images. Okay, even Jenkins application is also built as a Docker image. But whenever you try to install Jenkins on your server, what was the dependency? You need to install Java software. Okay, because this Jenkins is basically a Java application. It will only work if there is a Java software. Okay, if you don't install, it will not work. But if I'm taking like Jenkins Docker image, I need not install Java. Okay, why? Because the Java is already as part of this Docker image. Because this required Java as a dependency, that dependency is being included as part of this Docker image, so that I can directly take this Jenkins Docker image and run my application. Okay, so that application is going to run as a container. So this image is not going to like run as an application. This is just a static version. Okay, you can think like it as a file, some code file. But when you run this image, then only you are going to get the application, and that is the what you call as a container. Okay, so as I said, we have like container registries. So where all images are stored. Okay, images and ఎక్కడ స్టోర్ అవుతాయి అంటే container registry. All images are stored in this container registry. And we have like multiple container registry. Okay, so we have one thing, we have like Docker Hub. So Docker Hub is a container registry. And we have ECR. ECR means Elastic Container Registry. So this is a container registry from AWS. In Azure also we have one container registry, and that is called Azure Container Registry. Okay, we do have all this. Likewise, we have like Google Container Registry. So all these are nothing but where all the images can be stored. Okay, any application is like converted into a Docker image. This Docker image is basically stored in these container registries. This is a Google Container Registry. Okay. So like this we have. So if you are using like AWS cloud, okay, you can go for this one, Elastic Container Registry. Or if you are using like Azure, okay, so people will be using Azure Container Registry. Okay, so the people use this registers depending upon their cloud usage. If they're using Azure cloud, they can use Azure Container Registry. Okay, why? Because this is actually a paid service. To store images, you need to pay. But if you are using the cloud providers, they are going to give it for free. Okay, so that is how. But if you are storing like more, then there is some limit. Beyond that, if you are storing, they are also going to charge. Okay, now as yesterday I said, like to create an account on Docker Hub. Okay? So why? Because we are also going to build our own images. Okay, and also pushing to Docker Hub. And in Docker Hub, there are already some images are available. And coming, what is the difference between these three and the Docker Hub is? Docker Hub is a public container registry. Means the whatever images you are storing in the Docker Hub, everyone can be able to download. So there is a facility, you can make it a private registry as well. There, private registry means your images will not be available to everyone. Okay, only to the authorized persons it will be available. But most of the images here are like can be downloaded by any person in the Docker Hub. Okay, so to go to Docker Hub, we'll go there and see the images there in the Docker Hub. So you can go to hub.docker.com. Okay, so here where we have what they are telling, build and ship any application anywhere. Okay, why they are selling this is Docker Hub is the world's easiest way to create and manage and deliver your team's container applications. Why? Because all the images are stored here. Okay? If you click on explore, you're seeing like different images. Totally, you can see right how many images are there here. Okay, almost this many number of images, means every application is like converted as a Docker image. Okay, so and one thing is this image will be very less in size. Okay, so let me show you if they have kept this size or not, or I can show you after downloading as. So basically, what is Ubuntu? Ubuntu is an operating system. Okay, and this operating system also they have converted into Docker image, means anyone can pull this image and run it. And whenever you are running, one thing is yesterday I told you like Docker solved one of the major problem that was faced by the IT organizations. Means the application was working in one environment. Again, when we deploy the same application, same code in different environment, it is not working. Why? Because due to the differences, due to the mismatch between the code and the dependency it has. Okay. So now since we are converting, so that's the reason they are telling it you can run it anywhere. Okay, it's the same image. If you are deploying this image in the dev, staging and prod, so it's the same image which is we have pushed after developing an image, we have pushed to this container registry. Okay, as of now you can think container registry means any one of this, any one among them. Okay, so the image is stored here. Okay. So from here we are going to deploy the image into like multiple environments. Okay, like dev, staging and prod environment. Okay, so this way we'll pull the image. Okay, so the images are stored here to our environment. If you want to like get the image and run the application as a container, means there is a syntax, okay, to get that image downloaded to your environment. Okay, so using this command you are going to pull the image, docker pull and the image name. Okay, if you want to like pull some Ubuntu image, okay, you are going to use docker pull Ubuntu. So this is how you should use the images and get it to your local environment. Okay. If I'm going to like need some Ubuntu image, Docker pull Ubuntu. Okay. So what this will do is this will pull the Ubuntu image to your local. Okay. So later we can see how we are running the servers and all. So first we should get an image. And how they have like created an image, so they have made their operating system into one image. They've included whatever is required for to run an Ubuntu. All that together they have packed into a single file, and they have built it as an image, and that image they have pushed it to the container registry. Okay, so that's the reason we are able to, everyone is able to pull it. And Docker Hub is the container registry. Okay, so now to install Docker, okay, so first of all, to get the Docker environment, we should know the installation of Docker. So as of now, I am on Ubuntu server. Okay, to install Docker on Ubuntu server, the command is apt install docker.io. Okay, so using this command, you can actually install Docker. Okay, which is like apt install docker.io. Okay, so this is for what operating systems means, for Ubuntu or Debian operating system. Okay, for Ubuntu or Debian based, so this is the command. So next, if you want to install on CentOS, Red Hat, okay, so the command is like minstall Docker. Okay. Is for CentOS, Red Hat, and also your Linux CMA as well. So in Linux CMA, we have like two versions. So in one of the Linux CMA, we already have the Docker installed. Okay. Why? Because AWS knows these are like much needed softwares for every organization. Okay. So that's the reason they are like keeping it default for everyone. Okay, so these are the commands on Ubuntu, and these are the commands on like CentOS command. Okay, so I am already have logged into my server actually. Okay, now let me install the Docker. apt install docker.io. Okay, so this is my Docker version. Okay, 20.10.12. Okay, so Docker is there now. So let me see if the Docker is running. Okay, so Docker is running. In case if it is not running, okay, make it running. Okay, systemctl start Docker. So that will bring your Docker and your Docker will be running. So now I have my Docker. Okay, so Docker environment is ready here. So now I can interact. Okay, so here I am. So enter Q symbol here. It will exit from there. So what this has started is started Docker application container engine. Okay. So now we'll be able to use Docker. Okay. So now what I want to do is I want to like pull some images. Okay. So I also can build images on my environment, or if I can also like pull some images which has been developed by some other persons. Okay, some third party people as well. So how I'm going to do Docker pull and the image name, whatever image that will be, right. So I'm going to use that image. So I'm going to use Docker pull Ubuntu. Okay. If I use this, a Ubuntu image is going to be downloaded. Okay. So now the image is downloaded. Okay. So now if I want to see these images, right. So there is a command. So before that, we'll see what is a Docker image. As I said, Docker image is nothing but it's a combination of okay. So this is what Docker image is. Okay, so we also like seen how to pull the images. Okay, so Docker pull image name. Okay, it is going to get you the images. Okay, so to view Docker images, okay, so the command is nothing but Docker images. So once you want to see the once you have downloaded the images, once you want to check, okay, so this is the command. Okay, you are going to use Docker images command. So this will show you the downloaded images. Okay, this is the command. So I have pulled my Docker Ubuntu, right? So let me see that. Okay, if it has pulled or not. So Docker images. You could see, right? This is an Ubuntu image. It is having a tag. It is having image ID. And so when did it was the latest created? It was like 2 weeks ago. And what is its size? 77 MB. Okay. But and remember, this is an operating system. Okay. So you never get an operating system with 77 MB. Generally, if you tried installing your OS and all, minimum it will take like 1 GB or 2 GB to install an operating system. But since this application is converted as a Docker image, okay, it is coming in very smaller size. Okay, as I told you, all your applications when are converted into Docker images, they comes under very less size. They'll come with a very smaller size. So that is one of the reason. Okay, so it is going to occupy very less space. Okay, basically this is our EC2 server, right? So it is just taking very less space here. Okay, if you are like running operating system here on Ubuntu, technically will not be able to run on this because we get just one CPU and 1 GB RAM. Okay, but since it is coming like 77 MB, we'll be able to run the operating system. Okay, so similarly we can pull multiple images, but I have never told this anywhere like to pull it from Docker Hub. Okay, Docker pull Ubuntu, I told you. Okay, but there are like different container registries, right? So there is a Google container registry, Azure container registry, and also ECR, which is from Amazon, Elastic Container Registry. But it is taking from Docker Hub. Why? Because this is a public container registry. By default, if I don't tell from where the image should be downloaded, it will automatically pick it from Docker Hub only. Okay. So by default, wherever you try to pull images, it is by default going to Docker Hub and pull the images. So I can pull some other images as well, like Docker pull Nginx. Okay. So again, how can I see it? Docker images. So my images are downloaded here. Nginx, Ubuntu, all this. So similarly, Docker pull CentOS. So basically, CentOS is another operating system. Okay, but still I am able to pull it here. Okay. So now let me show you Docker image. So I have like Ubuntu, CentOS. Okay. So what is the advantage here is, so like there is an organization and they are developing some application. Okay. For that they need Ubuntu operating system to test, and also they want to test in CentOS as well. They want to test in multiple operating systems. Means they should have like multiple laptops with a different hardware. Okay, just for the testing the application. After that, they don't need it. But so what they can do, don't have any option. They'll try to purchase multiple machines within Ubuntu and CentOS. Okay, so this is what they do. Else they'll use some virtualization technique and try to install Ubuntu on one Ubuntu and also CentOS, okay, by sharing some resources to different operating systems. But what that can do is that might slow the operating system. Okay, so now if I want to like get a Ubuntu operating system with the Docker, what I can do is I can pull a Ubuntu Docker image, I can run it as a container, I can go inside that, I can work whatever testing I need to do, I can do the testing and remove this image or remove this container when I don't need it. So if I require a CentOS application, okay, so my application needs to be tested on CentOS operating system, I can run this CentOS as a container. So all this where they are running as, they're all running on my EC2 server only. And one thing the Docker doesn't be aware of is, so it doesn't know it is actually running on my EC2 machine. It what it thinks is itself it is running as an operating system. Okay, but it doesn't know it is basically running as a process on my EC2 server. Basically, all this like when I'm telling this as a containers, right? They run just as a process. Okay, so if I do like PSIUX, so it will show all what are the processes that are running here on my system. Okay, so these are the processes that are running. So similarly, when I run my application as a container, okay, it is also going to run as a container, but it is not aware that it is running on EC2. It thinks itself it is running as an operating system or like a standalone operating system. So this is how like we can see the images, and you can also pull the image based on its specific version as well. Okay, but I'm nowhere mentioning like Docker pull CentOS specific version I need. So when I mention like just Docker pull and the image name, what it will pull is it will pull the default. Default means the latest image version it is going to pull. That's why we are getting like 7 days, 12 weeks, 12 months ago. Okay, these are the like latest versions. So whenever I don't mention the tag, okay, any tag here after image, so it is going to pull the latest versions. These are like pulling the latest tags. So now you can see CentOS OS how much it is taking, 231 MB. And on top of that, I want to show you one more thing. There is something called Alpine here. Okay. So Alpine, if you see this, what is this? A minimal Docker image based on the Alpine Linux with a complete package index and only 5 MB in size. Okay. So what this Alpine is like, you are going to get a Linux operating system within just a 5 MB in size. Okay. So 5 MB means like how typically your images or files will be in this much size. But could you imagine you are taking an operating system in a 5 MB size? So Alpine is another distribution where they have created for this Docker. Okay, so if you want to get a Linux image with minimal version, okay, because if you see this Docker images, how much size they are taking, like though still it is less only when compared to your regular operating system size. If you are taking Docker images operating systems like Ubuntu CentOS, they are taking like smaller MB, so 77 MB, 100 MB. But if you take this Docker Alpine, Docker full Alpine. Okay. How much size it is? Just 5.54 MB. Means you are going to run a Linux operating system within this much size. Okay. So organization generally try to keep it the image size very smaller. So that's why they also take Alpine version as. If they are taking Alpine version, they are going to get a very smaller image size. So now we want to like we have the images. Okay. So I'll just show you the how this life cycle it is. How these Docker images are converted is, First, they need one Docker file. Okay, so this is the Docker file. They'll provide all the instructions. Okay, so the code plus dependency. They're going to provide all the code dependency instructions in a Docker file. Okay, so from this Docker file, what they are going to convert from Docker file, they are going to convert as an image. So if you are having this Docker images now, it means someone has written the Docker file. Okay, if Ubuntu is converted as a Docker image, they have written on Docker file. Okay, using which they have created Docker image and pushed into a Docker hub. Okay, so now this is the Docker image, and it contains the both. Okay, so now what is the next step? Once the Docker image is built, okay, so this Docker image will be stored in some container registry. Okay? So maybe I'll push it somewhere here onto to the top. So we'll have a registry here. And we'll call this as a container registry. Okay, so this is the next step. Okay. Let me remove this. Now, so where is my Docker image? It is in the container registry. Okay, you can think container registry is like a Docker hub, Azure container registry, ACR. So it can be pushed anywhere. So from container registry, what we are going to take, and again I'm pulling my image. Okay, and this image I'm going to run as a container. Okay, so container registry. So this is like we have developed. Okay, so we have developed a image. So this is the steps they follow. They'll create a Docker file using which they'll build a Docker image and they'll push into the container registry. Okay, so as a DevOps engineer, what we can do is we should take the image. Okay, where the image is here. So let me take my image from here. I'm going to pull it from here. Again, it is a Docker image now. Okay, so I have pulled it. Okay, so once there is a Docker image. Okay, so what next I'm going to do is I can run this as a container. Okay, so now we are going to pull the image and running it as a container. Okay, because I have my image. Okay, so now this part you can think like someone has developed it. Okay, so you can think some developer has developed some application. Okay, they have how they have like developed a Docker file. So they have taken something called Docker file. They provided all the instructions there. Okay, the code and dependency using which they have built a Docker image, and now they have pushed to container registry called Docker Hub here. Okay, so from Docker Hub we are pulling the images. Okay, how we are pulling? by using Docker pull image name. Okay. Once we have got the image, what is the next step we need to do? To run that image as a container. Okay. So that is the next part we are doing. And we might also do from all this, all the steps. Okay. Sometimes whenever the application doesn't have a Docker image, so the first step what we need to do, we need to write a Docker file for that. Okay. So we'll write a Docker file and build as a Docker image, and where the image is being pushed. Okay. So the image is being pushed to the container registry. Okay. And again from the container registry, we are pulling as well. We are pulling image from where again we are pulling it from the container registry only. Okay. So again we are pulling it image and again we are running as a container. Okay. So there is a possibility you might develop a Docker file from scratch as well. Okay. From here, or there will be already an image. Okay. The image will be somewhere in the registry. You might take that image and run that as a container. Okay. Container is nothing but your application is going to run as a container. And if you see on EC2, it is running like a process, one of the process. Okay. But this will run as a process, and how much resources it is required for that process. It is going to occupy from my host operating system. Host operating system is nothing but where actually it is hosted. Where it is hosted on my EC2 server. Okay. So now, so we do have all the images now. Okay. Now let me run as a container. Okay. So to run a container, we are going to use a command called docker run. So we have images. Okay, I'm going to run images as a Docker container. So how do I run? The command is docker run hyphen itd. If you want to give some name to the container, okay, so you can specify hyphen name. So what container you are going to give? You can like specify Ubuntu container. In case you are running a Ubuntu container. And now you should give the image name. Okay. So this is the name of the container you are going to give, because the image will run as a container, I told you, right? But the container will not have any name. Okay. But if you want to give it, is you can give this, but it is optional. Okay. No need to specify this mandatorily. So now I need to like which application I want to run as an image. So I'm picking like Ubuntu. Okay. Ubuntu image I want to run as a container. Ubuntu. Okay. So I need to attach a shell to this. Okay. So we have like a different shells like bash, and I'm going to attach this terminal to this. So this is the command. If I run this, okay. So basically, if you see, so rest of the commands will be same. Only thing which image I'm running as a container here, Ubuntu image. Okay. So rest of the thing will be same for every of this. Okay. Basically, I am running Ubuntu image as a container. So what is basically Ubuntu? It's an operating system. Okay, means there is an application that is giving me an operating system. If it is this is running as a container, so basically it is giving me an operating system. Okay, so let me run that. Docker run. Okay, I'll tell what are this. Okay, so why should you mention? Okay, so I told you, right, we can give the name to the container, whatever we are running. Okay, I'm giving my Ubuntu. Even you watch same problem. So it can be in any order. My this is nothing but my name of the container. Okay, so which image I want to run as a container? Ubuntu. Okay, and I want to attach a shell to this. Okay, now what is this is? This is your container ID. So whenever an application is like an image is running as a container, okay, a container ID is attached to the container. Okay, so now this is going to create a container. So now I want to see my Docker containers. Now we are going to see about the containers part. Till now we had images. Okay, so now I'm having like Docker containers running. Okay, so to view Docker containers. Okay, so now I want to view like Docker containers. Okay, so I can use this command. Okay, so what is the command? Docker ps. What this will do is it will show you the list of running containers. Means if you want to see what containers are running, okay, you can use Docker containers, because now you have created from the Docker image you created as a container. You want to see that, okay. And few things to note about containers is when a container is created, the container ID is attached. Okay. So whenever we are creating a container, okay, container ID is attached to the container. Okay. So it is reference. The container is referenced. We can refer the container with the container ID. Okay. So this is about Docker containers. Okay. So now to view the containers, this is the command Docker ps. Let's go there and see that. So this is Docker ps. Okay. So now you are able to see the container ID, right? Okay. So from when it is running here, 3 minutes ago it has been created. Okay. Up since 3 minutes. What is the name I have given? My Ubuntu. My Ubuntu was the name of the container. Okay. So this is how I am able to see that. Okay. So now the container is running. Okay. How I am able to see? With the help of Docker ps command. You can see the running container. Okay. So now I want to get inside this container. So basically, what is this container? So what container we have run? That మనం run చేసిన container ఏంటి అది base? It's a Ubuntu. Okay, it's basically an operating system, right? అంటే మనకి ఆపరేటింగ్ సిస్టమ్ కనిపించాలి. ఓకే, ఇఫ్ యూ వాంట్ టు సీ దట్ వీ నీడ్ టు గెట్ ఇన్సైడ్ ద కంటైనర్. ఓకే, so now we want to see getting inside the container. Now to get inside the container, we have another command. Okay, so we'll see. So I told you, right? We can refer the container with its container ID as well. Okay. So now anyways we got its container ID. Okay. So now this is how we are referring it. Okay. So again we can attach a shell here. Okay. So this is how we can get inside the container. Okay. So this is the command. Okay. So now let's get inside it. Docker exec -it. So what is my container ID? This one. So now where I am, DF B72852807. I'm inside my container. Basically, what is my container? Ubuntu, right?
Ubuntu.
So let me do ls. Okay. So this is what you will be able to see, right? Inside an Ubuntu operating system. Okay. So basically, whenever you log into your Ubuntu server as well, EC2 Ubuntu server, what is that by default you see? This Linux file system. By default, you'll be able to see all this. Okay.
Folders and files.
Okay, so this is the file system you're able to see. Now where I'm seeing this is not on my server, this is basically on my container. Okay, means on a Ubuntu server, on top of it I'm running another Ubuntu OS, but this is as a container. Okay, so similarly if I need like in CentOS, suddenly for testing some application I needed CentOS. Okay, so again I need not have some separate machine within CentOS installed on it. Okay, so I can take like CentOS image, run that image as a container, get inside that. So it is going to give me CentOS platform, CentOS server, so that I can work on that and come out of it. So similarly, nowadays every applications are like converted as a Docker images. All these Docker images are going to run as a containers. Okay. So the Docker image means it's a static version. Okay. The runtime version of the Docker image is a container. When you run only, it is going to run as a container. Okay. So where I am now, inside the container now. Okay. So if you want to come out, I can exit actually. If I exit, where am I again back? I'm
Server.
on EC2.
Ubuntu.
I'm on EC2 server. Okay. Again, if you see here, your Docker PS, that is still running. Container is there. Okay. It is running as an application. Okay. I told you, right? Basically, this container is running as a process. On your server, there will be like many processes running. Okay. Now your Docker is also running as a process here. It will take some process here. So something we could see right here. And you also can know the process as well, which is actually running as a process inside your server. So I can do the inspect. Now I can do inspection about the container. So how I can do inspection is Docker inspect container ID. Okay, if you inspect that, you are going to get more details about it. So Docker inspection. Okay. So what we do is we will get more details when we do Docker inspection. Okay. So to get the Docker inspection, okay, the command is Docker inspect container ID. Okay. So this is another command. Okay. So now let me clear the screen and inspect my Docker PS. Okay. So this will be show you the list of containers, right? So now I'm going to inspect this. Okay. Docker container ID. Okay. So I'm going to copy this container ID. So it is going to give more information about my Docker. Okay. So this Docker container is using an IP address here. Okay. This is my IP address of the container. And we'll see. So it is going to give all information about it. Okay. Which image we are using. Okay. Ubuntu. Okay. There is a volume. There is no volume. Going forward, we'll see Docker volumes concept and what network it is using overlay to. Okay. Going forward, we'll see which network is this Docker using. So you could see, right? Process ID, PID means this is my process ID of my container. Okay. 45,900. Okay. From it has started here. Okay. So what is this again? ID. This is my container ID. It is too long here actually. It can't display this much lengthy, right? That's why it's like a short container ID is being displayed there. But usually your container ID is this much in size, this much in length. Okay, when it is created, time and all, you want to know when it is created basically. So using which you can know here what is the status running. Okay, so and then it is using 45,900. It is using this particular process on your OS. Okay. So also like I showed you like PSUX as well. Okay. So you could see right here 45,900. So this was the port it was using there. Now if you kill that this process ID, if you kill this process ID, the container will be stopped. Okay, the container will no longer be running. Basically, it is a process. Okay, so if you can like stop or you can kill the process as well. Let me clear the screen. But in case I want to stop this container, okay, I can stop it as well. Okay, so that the command is docker stop container ID. Okay, now let me do docker ps. I am able to see any container now. The container is no longer running. Okay, why? Because I have stopped. Okay. So I have like stopped the containers. Okay, to stop the containers. Okay, so what command we are using? Docker stop container ID. Okay. So that's why I told you, right? We are always preferring our containers with the container ID in most of the cases. Okay. So this is the one command. Okay, you can use Docker stop container ID. Okay, so basically what we have done is, so we have taken some image from the registry. Okay, so we have run it as a container using Docker run command. Okay, so after running, we are seeing if the container is running. Okay, what is the command? Docker ps. We are viewing the containers. Okay, so now we had gone inside it. Okay, why? How did we go? By using the Docker exec command. Okay, and later how did we like get to know more details about it? By doing inspection, Docker inspect container ID. Okay, again we have been stopping it. Okay, Docker stop container ID. Okay, so again I can view the stopped containers as well. To view stopped containers and running containers. There is one command that is called docker ps-a. Okay, so ps-a means all. Okay, so it is going to show you the all the containers, whether it is stopped or started, it doesn't mind. Okay, it will show you the all the containers, docker ps-a. Okay, it is going to show you all this. Okay, now let me see this. Okay, so docker ps-a. Now it is telling, right, stopped. Okay, when did it exit? 2 minutes ago it got exited. Okay, so docker ps means, okay, it will show only the running containers, but now there are no running containers. Okay, but if you do docker ps-a, okay, so you are going to see the list of running containers and exited containers as well. But I do not have running containers, so it's not showing it here. Okay, but it is only showing the containers that are got exited. Okay, that you can view it by docker ps-a. So now I want to like permanently like remove my container. I don't want to have stopped as well. Permanently remove. Okay, so for that I'm going to use a command called docker rm and the container id. So now if I do docker ps-a also, I'll not be able to see any containers. Why? Because there are no stopped containers as well. Why? Because it has totally permanently killed. We have killed this container. Okay, what is the command for that? Docker rm. Docker rm is a command which is going to kill your containers. But you can't directly kill the containers. Okay, you need to stop it first. Okay, then only we can kill it. Okay, so this is how you can use docker rm and the container id. Okay, to kill containers. Okay, to kill containers permanently, we are using this docker ps hyphen, sorry, docker rm container id. And so I don't have any containers now. So if I do docker ps-a, it's not showing stopped as well, running as well. Okay. So let me clear my screen. So what I have only Docker images that are there here. I want to delete these images as well. Okay. I don't want the images to be stored here as well. So how I'm going to delete? Again, I can delete my images as well. Okay. So to delete my images, we are going to use a command called docker rmi. To remove images. Which command will use? Docker rmi image name. You could see the difference between removing the containers and removing the images. Okay, you are appending I here. Okay, so what will this will remove is this will remove an image. Okay, so this is going to remove your images. Okay, so now we'll remove the images. What is the command? RMI and the image ID. So if I, in case I wanted to remove this, okay, it is deleted. Okay, so similarly, I'll use Docker RMI, and this time I'll remove Ubuntu image ID. What is the Ubuntu image ID? This one. Okay. So how do I know if there is a remove images are removed or not? Docker images. Okay, you can see right, Ubuntu and Nginx were deleted. I can also like remove the images with a single command as well. Docker RMI. This particular image ID. Okay, we'll copy this image ID also. Okay, so it has removed two of these images in a single command. Okay, if I do Docker images, I don't have any Docker images as well. I'll clear my screen. But again, if I want to like pull images, again I can pull it again. Okay. Whenever I need an image, so again I can pull it. So a CentOS image is being pulled. Okay. So similarly, I can run a CentOS as also a container. Now, if you see like Docker images, then images will be there. Okay. This is a CentOS image. So try installing Docker and play with this. Okay, downloading images. Okay, and try to run as a container. Try to run as a CentOS as a container. Get inside. Okay, and see if you are getting that OS, whatever file system you have. You try to come out of it. Try to stop the container, kill the container, and also remove the containers. Try to inspect the container ID. And one thing what you can do is try to kill the process ID. Okay, to kill the process ID, you can use kill command, kill and the process ID. So the container will be stopped. So basically, you will know that container is basically a process. Okay. Okay. So that is what I had for today. Okay, I'm stopping it here. Okay. So tomorrow we'll see how to. So today what we have seen is like we have taken the images that are already built. Okay, from the Docker hub. Okay, as I said, right. So this is the life cycle of Docker. So right from the Docker file, you build a Docker image. From the Docker image, again you are going to create a container. Okay, but we didn't deal with the Docker file today. Okay, so we already have taken an image from where container registry. Okay, which is the Docker hub, and we try to like use this existing images from Docker hub and create it as a containers. And once we have created the containers, we did few things. Okay, so how to view the running containers like Docker ps to get inside the container. This was the command. To do inspection, so this was the command. Again we have stopped the container. Again we have like permanently removed the container as well. Okay, later we have like removed the images as well. Okay, so why? Because if the images are there, they are going to occupy some size, some space on your server. Okay, but if images are no longer being used, you can delete. Why? Because images anyways are being there in the registry. So whenever you need, you can pull then only. Okay, if you don't need, you can remove that, so that you'll have some space on your server. If you have any questions, you can ask me. I'm stopping it here.